Okay, so today we're going to continue our discussion with variation. We're going to be talking about combined variations or sometimes joint variations. That's where we take direct and inverse variations and combine them with other things. Let's get started first by talking about some examples of what combined variations look like. First example, area equals 1/2 base times height. We would say this is a direct variation question, but there's two variables here. And so we could do this one of two ways. We can say that A, that's the number that it is isolated on the left of the equation, varies jointly with B and H. Okay, so jointly implies that they are both variables that we're talking about are direct variations. We could also say that A varies directly with both B and H. That would be the same thing. And the reason we know it's directly is because we're multiplying by those two variables. The 1/2 is the K value. Another situation, we have another familiar equation that we have, area equals pi r squared. And so this time, there's two variables, but they're the same thing. It's r times r. So that's just simply r squared. The K value is pi, and so we would say A varies directly with the square of r. Let's take a look at this third situation. Here we have the volume is 4/3 pi r cubed. That's the volume for a sphere. We have one variable. The K value is 4/3 times pi, so this whole thing represents the K value, and we would say that A varies directly with the cube of r. So those are some examples of direct variations where we have more than one variable that's varying directly. Let's take a look at some more. This is not a direct variation because we're dividing by both x and z. They're both inverse variations. And so we would describe this by saying y varies inversely with x and z. The 64 would be the K value. Another situation here. Here we have three different variables and we have three different things, or at least two different things going on. The 4 is the K value, and then it varies directly with w and x and inversely with n. So m varies directly with w and x and inversely with n. I want you to get familiar with how these are described because we're going to be writing these equations here shortly. All right, so let's try some on our own here. It says write a general equation that reflects the following situation. So y, so that's our variable that's by itself, varies directly, so we're going to have a K value. It's going to vary directly with n, so we're going to multiply by n, but inversely with m, which means I'm going to divide by m. Let me try this again. There we go. Inversely with m. And so we have a K value. Now that K value, if we were writing an equation, would have to be a specific number, but we don't know what that number is right now, so we're just going to write it as K. Take a look at number 8. And you might want to try these on your own before I get to them. Maybe pause the video and see if you can figure them out before I do. Hopefully you've done that. We're going to say that W varies directly with the square of P. So that means we are going to have a K value. It's going to be directly with the square of P, but inversely with R. So our equation is going to be some number. We're going to have a number in here eventually, but right now we're just writing how these will look. W equals K times P squared divided by R. And it's divided by R because it's inversely with R. Last one here, number 9, Z varies inversely with the cube of G. So we're going to have a K value. I'm going to put that on top. But because it's varying inversely, I'm going to divide by G cubed. And so we're going to have an equation that looks something like this. Well, let's get to a situation here so that we can write an equation. Here we have what we started with the last 2 or 3 questions. Y varies directly with x. So I'm going to start with y. I'm going to have a K value. And it varies directly with x. And so we have our K value, and it varies directly with x and inversely with z. And so that's what our equation is going to look like, but we don't know what the K value is yet. So we're going to have to plug in some numbers so that we can figure out what the K value is. So we have, the next sentence says that y is 25, so I'm going to replace the y with 25. I don't know what K is, but it says y is 25 when x is 10. So I'm going to put a 10 in for x, and when z is 2. And so now I want to figure out what the K value is. So I'm just going to multiply both sides by 2. So I'll have 50 equals k times 10. Divide by 10, and k is 5. Which means my real equation with the k value in it is going to be y equals 5x over z. So there's my equation. There's my specific equation with the appropriate k value. And then it says figure out what y is when x is 14 and z is 7. So my y value is going to be 5 times x, which is 14, divided by z, which is 7. That's a 7 there. That's the same thing as 5 times 2, so my y value will be, 10. And so that's what we're going to be working on our homework assignment. Different k values, different relationships, but we're going to have to figure out what the specific k value is and then use that to find other values. Let's take a look at one more. Here we have the body mass index, BMI. This is wrong here. So body mass index, and we know that your body mass index has a k value, but it varies directly with your weight. So as your weight goes up, your body mass index is going to go up, but inversely with the square of your height. So the taller you are, as long as you weigh the same, the lower your body mass index is going to be. And you don't want to have a body mass index that's very high because it's unhealthy. You can see here the different labels that they're giving here. We have anywhere from underweight to extremely obese here. And so what we're going to do is figure out what this equation is. And what I'm going to do to figure this out is I'm just going to pick a specific value at random. Let's say I pick this 22 here. That's going to be somebody that is 5'7" and somebody that weighs 140 pounds. 5'7", 140 pounds, and it's 22. And so I'm going to move over to the next slide here, and the variation that we know goes back to our general equation where your BMI, your body mass index, is equal to some k value times your weight divided by your height squared. And so we're going to plug in specific values. The values that we are picking is that our body mass index of 22, I got to go back and so I can draw here. Body mass index of 22 is what you would get if you had a person that weighed 140 pounds and was 5'7". Now we're going to have to convert 5'7" into just inches. And so 5 feet, that's 5 times 12, that's 60, plus the 7, that's 67 inches tall. And so now what we're going to do is figure out what the specific k value is. And so I'm going to take the 22 and multiply it times 67. So 22 times 67 is 1,740 or 474. That equals k times 140. Then if I divide by 140, I'm going to get 10.52. So k equals 10.52. So that means our equation for your body mass index would be that your body mass index is equal to your k value, which is 10.52 times the weight divided by h squared. And so what we're going to do is just pick somebody here at random. Let's say that we have somebody that is 6 feet tall. So if they're 6 feet tall, that means they are 72 inches tall would be their height. And let's say that we have somebody who is 6 feet tall and weighs 180 pounds. So their weight is equal to 180. And so we want to figure out their body mass index. So I would take 10.52 times their weight, which is 180. This is a 2 here. And I would divide that by their height, which is 72 squared. And so let's see what we have here. I'm going to take 10.52 times 180, and I'm going to divide that by 72 squared. Okay, something didn't go right here. Okay, so after looking at this a second time, I started with the wrong equation. The equation should be this, that your body mass index equals K times W squared over your height. So I had the wrong thing squared. So it varies directly with the square of your weight and then inversely with your height. That's going to give us a different set of values. What we did mathematically was correct all here, but it doesn't give you the correct body mass index because this came out to be a decimal and that's not correct. But if we were to do the same thing over again with this equation, we would end up with a K value of 0.075. And then if we plug that into this equation, the same values into this equation, we take a person that the K value is 0.075. We take a person that weighs 180 pounds and then divide that by, we said the weight and square it because it's W squared. And then we divide that by a height of 72. We would get a body mass index of right around 33. And if we go back to the previous slide, we can see that we did that equation pretty accurately because here's a 180 pound person, which means we're in this column. If they're 6 foot, that means we're in this row here. And so you can see they have 34, we had 33 point something. And so our equation is pretty accurate based on, at least the second equation, based on what the body mass index chart looks like. Anyway, you get the idea of what we're going to be doing here mathematically. And so this is assignment number 3. You can go ahead and work on that, and we will see you tomorrow in class.